Hello everyone, good day. So for this video, we will be focusing on the chemical bonding, specifically the ionic bonding. Okay, so before we proceed with the discussion on the ionic bonding, let's review first the related terms. No, let's start with an element. So element is a pure substance that cannot be broken down. So very simple, you simply check your periodic table of elements and all of the elements listed there. Mo nang tawag nato elements. Second, we also have the term molecule, which is basically a group of two or more atoms held together by chemical bonds. No? So these are hydrogen molecules, the oxygen gas molecules. And the third term is called a compound. So molecular compounds or simply compounds are combinations of different kinds of elements in a fixed proportion by mass. So compounds are also considered as molecules kasi nga ano siya, two and or more atoms held together. So example, we have a water and hydrogen peroxide. Next term is we also have here the ions. So ions, it's very useful for our discussion on the ionic bonds because it focuses on the ions. Very simple. When an atom gains or loses electron, ang tawag sa kanila ion, no? So if an element will really or will lose electrons, ang tawag sa kanya is cation. Then if an atom will receive or will gain electron, ang tawag sa kanya anion. So more of that will be discussed later. Next, a chemical formula. So a chemical formula is basically a shorthand way of writing the name of the element. So it looks like this. Example, if you have Br2, that is the chemical formula of bromine. So in this case, you have Br as the symbol for the bromine, and then the 2 there at the bottom, it represents the molecule of the atom. So ilang bromine atom yung nandyan? So we have 2 bromine atoms. For the water, you have hydrogen, H, and then O for oxygen. Then you have here 2, which represents the number of hydrogen atoms. So ibig sabihin nito, merong dalawang hydrogen saka isang oxygen. Okay, so we will now start with the chemical bonding. Ano nga ba yung chemical bonding, no? So, in this case, we have here a chemical bond definition, which is the attractive force that holds the atom together. Anong ibig sabihin nito? So, in this case, if we have two atoms, this bond between two atoms is just a representation. It is not an object. Ibig sabihin, the chemical bond is not a part of the sequence, or it's not a thing, no? It's not an object. It's simply a force there that represents something that holds them together. Now, in this case, for example, you have here two atoms of hydrogen. No. So, we have here 3 relationships or 3 interactions, no? So the first one is the repulsion between protons. Kasi nga, it's the basic knowledge that same charges repel. Now, if we are talking all about 2 hydrogen atoms, yung isang hydrogen nun, meron siyang isang proton. Then the other hydrogen atom, meron din siyang isang proton. So there is a repulsion or repulsive force between the 2 protons. Same with the electrons. Kasi they have 1 proton tsaka 1 electron. So ibig sabihin, there is also a repulsive force, or there is repulsion between the electrons. And the third one, attraction, it's between the protons and the electrons. Kaso hindi it's not clearly specified here, but that's the case. The third one, it's the attraction between the proton and the electron. It's the repulsion between 2 protons, and it's the repulsion between 2 electrons. So there should be an enough, no? There should be an enough space between these atoms. Kasi if it's too close with each other, that's not gonna happen because there are 2 repulsive forces here. Repulsion between protons and electrons. Diba? Kung masyado namang malayo, it's not, it's not enough to say that they are really bonded chemically. So there should be enough distance. And that enough distance favors our bonding, no? So that there should be enough distance. And this bonding between 2 or more atoms are generally classified into 3, no? We have the ionic bonding, which is the complete transfer of electrons between a metal and a non-metal, and it looks like this, which will be the main topic for this video. Next is a covalent bonding, which is basically the sharing of electrons between two nonmetals, and it looks like this. And the third one is a metallic bonding, which is the electrostatic attraction between the positively charged atom nuclei and the localized electrons. And it looks like this. Okay, so those are the three types of bonds. Now, these bondings are very not necessarily, they're very important to be able for these compounds to be stable and to be able for these compounds nga ma-emphasize ang ilahang mga uses. Okay, now in this case, we have here the Lewis dot structure. So the Lewis dot structure is, it consists of dots. Basically, it represents the valence electrons. So when we say valence electrons, these are the electrons in the outermost shell of these elements. Now, the Lewis dot structure is very useful because it shows the movement. In this case, since we're focusing on the ionic compounds, it shows the transfer and receiving or it shows the transferring and receiving the electrons. Okay, so this is Gilbert Lewis, which is the proponent of this structure, and these are the structures based on our elements. So, example, all of the elements under group 1A, ibig sabihin nun, they only have one electron in the outermost shell. So you will only see the symbol for lithium, for example, and one dot. Then all of the elements under group 2A, dapat sila duha lang ka-electrons. So you can see there 2 dots until siya sa group 8. So when you say group 7A, that means there are only 7 electrons in the outermost shell, the valence electrons. That's why you can see also there a fluorine and 7 dots. And then for 8A, ito yung mga noble gases. So we have here 8. No? You have the symbol at the center, then you have there the dots at surrounding the symbol. Basically, there's no specific way of writing the dots. Others are saying it should be clockwise, or it should be counterclockwise, or whatever. But you should always remember to take it into consideration the direction na lang. Example, in this case, we start here in the right side, no? Tapos, when we proceed with group 2A, at bang na siya. And then 3, and then 4, and so on and so forth. So, it's not specific good nga. You should always start to the left or to the right. So, it depends upon your author. Okay? It depends upon your author. And then, we also have here these electrons. They are paired electrons, no? So, meaning nakapare sila, tagduha. You also have here, let me zoom it in. Here, you focus, in the nitrogen, you have 2 electrons, which are paired together. But there are 3 electrons nga wala sila partners, no? So, that's how we interpret the Lewis dot structure. Now, remember that all the elements within a given group, with the exemption of helium, have the same number of valence electrons. So just like what I emphasized a while ago, all of the elements under group 1A, isa lang ang ilahang valence electrons. All of the elements under group 7, 7 rapod, and until group 8A. Now, therefore, they have the same number of electron dots, just like what you see here on the screen. But the position of the dots in a Lewis structure are arbitrary as long as there is a maximum of 2 dots per side of the element. So in this case, if there are 4 sides surrounding the element, the perfect number surrounding, or the perfect number of dots surrounding the symbol should be 8. Now, what is this rule? So this is, before that, we have here the Lewis dot structure of the elements. So in this case, it's very simple, no? Usually, ang grabe good maka-react, especially when we're talking all about ionic compounds, are groups 1 and 2A for the metals, and then groups 13, 14, 15, 16, and 17. They are usually good nga sila lang ang medyo grabe ka reactive with each other. Okay, now, why is it that the elements under group 18A or 8A, dili man kayo sila reactive? And why is it that there are only 8 dots surrounding the symbol using the lowest dot structure? It's because of what we call as the octet rule. So the octet rule states that to attain maximum stability, an atom needs to share, gain, no, or lose electrons until 8 valence electrons are found on its valence shell. Anong ibig sabihin nito? 8 is the stable number for all of these atoms. Ibig sabihin, if you're lower than 8, like 6, 3, 4, meaning the atom or the element should look for ways para mas stable siya. It could be iyang i-give up ang sobra niya, or it could be pwede siya mo accept, or it could be pwede siya mo share. That's what we mean by the octet rule. So in this case, this is what's happening. In the neon and the argon, you can see there on the outermost shell, we have 1, 2, 3, 4, 5, 6, 7, and 8. Then 1, 2, 3, 4, 5, 6, 7, and 8. Ibig sabihin, these elements belong to group 8A. So the number of valence electrons 8 also. So they are more stable than others. They are the most stable elements or atoms compared to others. Okay? But remember, there are exemptions. Ang pinakaunang exemptions ang atong hydrogen and helium, which they follow the duet rule. Kasi nga naraman sila sa isa raman electron nya isa group 2, so ana ra gyud. The beryllium also can accommodate 4 electrons on its outermost shell, so mao na siya ang yang exemptions. But remember, atoms like nitrogen with an odd number of valence electrons are also exempted to the rules kasi odd, di ba? Odd ba siya? So an element in the third period can occupy more than 8 electrons in the outermost shell due to a higher d orbital, and this is called an expanded octet. But basically, the basic rule of this should be 8 ragyo dapat ang nasa iyang outermost shell. But these are just exemptions. Less than 8 and more than 8. But in this case, I'm just showing you we are only focusing muna on the octet rule here on this case, okay? And also in our next discussion. So in this case, upon or after showing you how the Lewis dot structure is written and also the relationship of that structure to the octet rule, we will now proceed with our main topic today, which is all about ionic bonding.